ampere. For temperature we have Kelvin. For luminous intensity we have candela, and for amount of substance it is mole. And the supplementary and very important units of measurement are: for plane angle the unit is radian, and for the solid angle the unit is steradian. So whatever measurements we are making in India, they should have same digital value as and when it will be measured in England or Japan or America. For these reasons we need to follow the standards. We need to have some standard of unit, and we will be interpreting accordingly. So measurement is of considerable importance in engineering, and it is required at all stages of manufacture. The earliest length standard was the Egyptian cubit, which was distance from elbow to tip of outstretched finger. So you can just understand how measurement was being considered in the older days. It was not an accurate way of doing, because everybody will have a different distance of elbow to tip uh, when the middle finger is outstretched. And it is very surprising and funny as well that the foot was defined as length of actual foot of reigning monarch. So as the monarch may be changed, the size of the foot will change at that time. So these were the ways followed for taking any measurements in the old days. And it is interesting to note that length of some so-called standard varied within one country. The cubit of various lengths ranging from 450 mm to 670 mm. So for different regions the measurement lengths were different. So there was a need for finding out a standard that will be followed up globally, to which all of the countries will agree. And in the 18th century, Austrian map showed miles of different lengths. As early as 1805, Maudslay had developed a micrometer which was used in his workshop to settle disputes regarding measurements. Maudslay referred to it as Lord Chancellor. It was more of a measuring machine than an instrument. The instrument was provided with a pitch of 0.01 inch and had an index wheel of 100 divisions, and as such one division represented 0.0001 inch. The first handheld micrometer was produced in 1867. It was designed for taking measurement of sheet metal. It was becoming obvious that more accurate measurements must be made by comparison with standard of dimension. Such a standard is known as primary standard and is in form of line standard. Rapid advances made in engineering during 19th century were due to improved material available, and more accurate measurement techniques were developed. Further, with coming of interchangeable manufacture, a natural demand for more accurate measurement stimulated the French and British government into producing new and more accurate standards of length. It wasn't until 1855 that first accurate standard imperial standard yard was made in England. This was followed by international prototype meter in France. So these two standards, the yard is of 36 inches while the meter is of 100 centimeter. The 36 inches yard is divisible with inches, and 12 inches a dozen um, is the part of the yard measurement, while in case of prototype meter the divisions were done in centimeters and millimeters. So it is a metric system which is easily divisible by, the measurements are more easily divisible by tens of units. So, next we discuss material length standards. So, first one is the imperial standard yard. It is shown in the figure below. So, this imperial standard yard was first time produced in England, and the composition of this yard was they used 82% of copper, 13% of tin and 5% of zinc. So, this is a bronze bar which is having copper, tin and zinc. And in this imperial standard they had kept two hole recesses, that is on the left hand side and the right hand side, and we can understand over here that the height of this bar over here, the imperial standard yard, is about 1 inch, and it had similar cross section on the other side, that is the actual cross section of this imperial standard yard is 1 inch into 1 inch. And on the left hand side and right hand side we have two small holes. In these holes they had placed gold plugs on which there was um, engraving as shown in this figure over here. So, these gold plugs had these fine engravings. So, the length was considered as on these engravings from this point to this point on the other end. So, the point to be noted is that these engraving is done on the neutral plane which lies or crosses through the neutral axis. So, this was kept at the neutral plane or the neutral axis, and within this depression the engraving is done on this plug which is in depression over here, so that these lines do not get damaged. The imperial standard yard as shown in figure is alloy with 82% copper, 13% tin and 5% zinc, bar of 1 inch into 1 inch cross section and 38 inches long. The round recess 1 inch away from two ends is cut at both ends up to the central plane of bar. A gold plug 1 by 10 inch in diameter having lines engraved transversely and two lines engraved longitudinally is inserted into these holes so that the lines are in neutral plane. Yard is then defined as distance between the two central transverse lines of plug at 62 degree Fahrenheit. So, they are taking care of the temperature at the time which they are explaining the measurement size as 1 yard, that is 36 inches. The purpose of keeping gold plug lines at neutral axis has following advantages. Due to bending of beam, the neutral axis remains unaffected. The plug being in a well is protected from accidental damage. Though the imperial standard yard was widely adopted, yet it is interesting to note that American standard yard is slightly longer than imperial standard yard. So, different standards are being used, were being used at different places. America was using something else, England was using something else. The imperial standard yard, being made of simple bronze, was not was not stable and continuously shrunk at rate of 1 million of an inch for the past 50 years. So, with this calculation, that is 1 millionth of an inch every year makes it about 80 microns in 10 years. This was sufficient to seriously affect fine measurement and also conversion factor for metric working. So, the standard imperial yard is to be kept over here like this. It should be, when it is in the resting position, it should be rested over these 8 supports over here, number 1, 2, 3, and likewise there are 8 supports over here for the imperial standard yard, so that it does not form any deformation over a long period of time. So, these 8 supports are supported by 4 supports below, and these four supports are supported by these two supports below. So this kind of system, supporting system, was developed in 1922. An attempt was made in 1922 to overcome this shrinkage by measuring the yard oblique meter relationship in that year, specifying it as a legal size. So it was accepted between the Americans and the English people, the British people, that a yard is equal to 1 yard is equal to 0.91439841 meter. This was accepted in 1922. So next is our international yard. The increasing demand for accurate international interchangeable engineering devices and the problems arising from the varying ratio between the imperial standard and American standard yard and prototype meter was resolved in 1960. The United Kingdom, Canada, America, Australia and South Africa agreed to adopt an international based upon the meter. So they took 1 yard is equal to 0.9144 meter. So these companies, these countries which agreed upon this fact to adopt 1 yard is equal to 0.9144 meter were the advanced countries who were doing very well in the manufacturing field. So next we discuss international prototype meter. So when a metric system of weight and measurement was originally founded, the meter was intended to be 1 millionth part of polar quadrant of Earth passing through Paris. Measurement of Arc, Dunkirk and Barcelona were completed in 1798, and following year a platinum bar corresponding to 1 meter was deposited. This served as metric length until 1875, when it was replaced by platinum iridium international prototype meter. The length of meter is defined as the straight line distance at 0 degrees centigrade between the center portions of pure platinum iridium alloy of 102 centimeter. Total length and having cross section as shown in the figure. So this prototype meter is having this kind of cross section. It is a web design, and this whole of the material is made from platinum iridium alloy. They used platinum iridium alloy for the reason that it is more stable and the size remains the same over passage of time. So this engraving over here on this end, transverse line is there, and similarly a transverse line is on the other end, and the gap between these two transverse lines was taken as 1 meter. And we can see over here the cross section on both sides is 16 mm in height and 16 mm in width. So this kind of a structure used less of expensive material and it was more stable, and because this engraving is on neutral plane or the neutral axis, it is saved from any kind of damages that are possible. The graduations are on upper surface of web which coincides with neutral axis of the section. This shape has two distinguished advantages. Number one, sectional shape which gives greater rigidity for amount of metal involved and therefore is economical in use of such expensive material. The section shape gives greater rigidity for the amount of material used. So again here in the drawing we can see in this figure that the marking is done on the neutral axis. So we discussed disadvantages of material standards now. There are many problems and difficulties associated with above two material standards. Number one, the material standard varied in length over the years owing to molecular changes in alloys from which they were made and thus seriously affecting the fine measurement. The replicas of two standards are not available elsewhere. If these standards accidentally become damaged or destroyed, then their exact copies cannot be made. So, these are some of the disadvantages. And another disadvantage is conversion factor was to be used for changing over to metric working. So, finally, the world accepted for the light wave optical length standard because this was repeatable and was available in all countries. This can be available anywhere. And the early standard meter established at time of French Revolution was supposed to have its length to be 1/10 millionth of quadrant of Earth's meridian passing through Paris. This definition of meter in terms of some natural standard shows an early trend to define length without reference to metal bar. Also, because of problems of variation in length of metal bars, the possibility of using light as basic unit defined primary standard has been under consideration. So, I hope you are benefited from this lecture. Thank you so much.